Welcome to this explainer on the Android activity lifecycle and intents. Have you ever stopped to wonder what actually happens behind the scenes when you open an app? Quickly switch over to answer a text message and then pop right back into the app. Well, today, we are taking all that dry code and turning it into the biography of a living, breathing application. We're going to explore exactly how an app is born, how it lives its life, and eventually how it shuts down. Here is our roadmap for the explainer. First, the secret life of apps. Second, birth in the spotlight. Third, paused, stopped, and destroyed. Fourth, moving between screens. And finally, your coding mission.
All right, let's jump right into section 1, the secret life of apps.
To make this whole lifecycle thing click, I want you to think of an Android activity as an actor on a stage. They actually transition through 5 main states. First, there's starting. They're basically getting into costume, loading up, but not quite ready for the audience. Then running. Boom. They are center stage, fully visible and doing their thing. Paused means they're slightly obscured, maybe just standing in the shadows while another character speaks. Stopped means they've left the stage entirely, but they're still waiting in the wings, kept in active memory. And finally, destroyed. The show is absolutely over, they've gone home, and they are completely shut down. So let's look at how our actor actually gets ready and steps onto that stage in section 2, birth and the spotlight. It all kicks off with a method called onCreate. You can really think of this as the absolute birth of our activity. This is exactly where it puts on its costume and sets up the stage layout. In your code, this is where you're going to load your static resources, set up the menus, and bind those visual layouts. It's basically the constructor. After this method runs, the activity object officially exists. When an activity is launched, onCreate is that very first step. The system calls this before absolutely anything else. The user taps the app, the process starts, and bam, onCreate fires right up. Now, right after onCreate, the activity briefly passes through a state called onStart, but the real magic happens when it hits onResume. This is when our actor officially steps into the spotlight. When onResume gets called, your activity enters the running state. It is fully visible on the screen, your animations start firing, and the user can finally interact with your buttons and text fields. Resume brings the activity directly into that active running state. And honestly, it just hangs out in this loop as long as the user is actively engaged. If the app happens to lose focus for just a split second but comes right back, it loops straight back into resume. But what happens when real life interrupts? The phone rings or the user switches over to answer an email. Let's figure that out in section 3, paused, stopped, and destroyed. Okay, it is absolutely crucial to understand the difference here between on pause and on stop. On pause is like the actor just stepping slightly back into the shadows. The activity is still partially visible, maybe a little transparent dialog box popped right over it. This is exactly where you want to pause heavy CPU animations or save quick draft changes. On the flip side, on stop means they have completely left the stage. The user went back to the home screen or opened a totally different app. This is where you do your heavy-duty shutdown tasks, like writing data to a database. So why does on pause actually matter so much? Well, think about it. If your app is paused, the user isn't actively interacting with it, but it could still be quietly eating up resources in the background. By properly using on pause to stop those animations and release system resources, you are directly saving the user's battery life. And honestly, that is the hallmark of a really well-coded Android app. Eventually, the system might just need to reclaim some memory to run other things, or the user totally swipes your app away. That triggers on destroy. This is the end of the line. The entire app is shut down and wiped from memory. And because it's pretty unpredictable exactly when the Android system might decide to call this, it's always a safer bet to save your crucial data earlier, in on pause or on stop. Now, as you're coding, all these state changes are happening invisibly in the background. To actually track them, you're going to use Android Studio's Logcat console. It's a brilliantly simple tool. You've got logd for your basic debugging, log-e for fatal errors, log-i for simple info, log-v for super verbose details, log-w for warnings, and my absolute personal favorite, log-wtf, which actually logs the stack trace of a terrible exception. Dropping these log methods into your lifecycle states is literally the best way to see exactly when your app pauses, stops, or resumes. Of course, a single actor does not make a play. Most modern apps have way more than one screen. So in section 4, let's talk about moving between screens with intents. The big thing here is understanding what an intent actually is. Think of it as a magical transportation system. It's an object that tells the Android OS that you have an intent to do something. Specifically, that you want to navigate from your current activity to a brand new screen and maybe bring some data along for the ride.
Let's see what this looks like in practice. When you build a nice clean UI like a homepage, you'll jump into Android Studio to wire up those buttons. You'll create on-click listeners, and right inside those listeners is where you trigger these intents.
And here is the actual spell you cast. This concise little snippet of code is the intent in action. You declare a new intent object, telling it exactly where you are right now, using the keyword this, and where you want to go, like secondactivity.class. Then you literally just command the app to open that screen by calling start activity. It really is that simple to move users around your application.
All right, now that you've got the theory down, it is time for Section 5, your coding mission.
Before you start typing away, let's quickly cover the lab rules. Arrive on time, folks. There's a strict 15-minute max grace period. Keep the lab computers purely for course activities, so no scrolling social media. Absolutely no food or drinks near the machines. Save your work constantly, log off when you're done, and submit those reports with screenshots and code via eCampus. And a massive reminder, submit original work. Plagiarized or identical reports get an instant score of 0. Let's keep it fair and keep it fun. So here is your week 3 assignment. You're going to build a functional app with 1 to 3 connected activities. In the main activity, you'll set up some input fields where a user can type in a product they want to buy and the quantity. Then you'll wire up a checkout button. When they click that, the button needs to fire off an intent to navigate to the second activity and actually display those exact purchase details. So, as you head into the lab today, I am leaving you with one big puzzle to solve. You know how to use an intent to open a new screen, but how exactly are you going to attach that extra product data, the item name and the quantity, to your intent so the second screen actually knows what was bought? Check your reference materials, play around with the code, and good luck.